We are solving question number 46 of GATE 2014 chemical engineering paper related to process control and instrumentation. And the question is, given below is a simplified block diagram of a feed-forward control system. The transfer function of the process is Gp is equal to 5 upon s plus 1, and the disturbance transfer function is Gd is equal to 1 upon s square plus 2s plus 1. The transfer function of the perfect feed-forward controller g of s is dash. So here we have been given a feed-forward control system, and corresponding to that, we have been given the process transfer function Gp of s and the disturbance transfer function Gd of s as well, and we have been asked to find the transfer function for this feed-forward controller, that is Gf of s. So let's just write the output equation. And for this feed forward control system, that is, for if you want to implement this perfect control, that is the whatever the set point is, that should be achieved. That is basically the set point change should be 0. It is whatever the set point trajectory we have been providing, that should be achieved by the system. That is when we can say that we have achieved the feed forward control is acting perfectly. So no matter if we are providing disturbance also, then also the set point should be achieved. Then only we can see that we are controlling perfectly. So that is, we will be finding this output equation ys and replacing it by 0 to find this feed forward control system. So to find this ys, we can write it as y of s is equal to, basically it will be summation of the output in at these two nodes. So let's just find what should be my values at this and this 2 point. So over here, my input or the disturbance is D. So over here also it will be D. Now, since we are having a block in between, so usually the transfer function is output upon input. So output will be G into input. So over here, the transfer function G is Gd and the input is D. So it will become Gd into D. This is at this point. Now again, similarly at this point, the output will be disturbance into G of f. Now again, since we are passing through this transfer function block of Gp, that is process transfer function, the output after Gp of s will be G of s Gp into D disturbance. That is, we can write this ys as summation of both of these values, that is Gd into D plus Gf Gp into D. So let's just write it as G of f Gp D plus Gd into D. So all of this will be in terms of S domain. So now let's just write it over here. So y of s is equal to Gf Gp into disturbance plus Gd into disturbance. Now for perfect feed forward controller, as we discussed, we have to replace this y of s as 0. So we'll write it as 0. So this will become Gf Gp plus Gd. This disturbance term will become common. So from solving this, we can find this feed forward control function, that is G of f s. This is P, will be minus of Gd upon Gp. Now we can replace the individual transfer function values. So the disturbance transfer function value Gd we have been given as 1 upon s square plus 2s plus 1. And for process, we have been given 5 upon s plus 1. Now this is s plus 1 whole square. So we can replace the denominator as s plus 1 whole square upon 5 upon s plus 1. This will get cancelled out, and we get the value as, over here there is minus 1 upon 5s plus 1. That is the transfer function for a perfect feed-forward controller. G of s we found out to be 1 upon minus 1 upon 5s plus 1. So this is our final answer. So we can select this option C, where here is the correct answer.